Hey guys, welcome to 2.6 Related Rates Day 2. In this lesson, we're going to be doing an extension of Day 1 with more examples. As I mentioned before, related rates is a application of derivatives and implicit differentiation. So let's begin with the first example. A fish is reeled in at a rate of 2 feet per second from a bridge that is 16 feet above the water. At what rate is the angle between the line and the water changing when there are 20 feet out, line out? So let me go ahead and draw a picture. And that is one thing that you want to do when you're doing these types of problems is always draw a picture. It helps you stay aligned with what the problem's asking. So I have a bridge, and there's the water. And I'm reeling in this fish at 2 feet per second when the bridge is 16 feet high. Okay, so I have a 16-foot high bridge. My line is extended out into the water, and I'm bringing in this fish at a rate of 2 feet per second. So 2 feet per second is how fast this green line is changing. Okay, so and then the question asks, at what rate is the angle between the line and the water changing when there are 20 feet of line out? So 20 feet of line is out, and the angle between the line and the water is right here. And I'm asked to find the rate of the angle changing. So what does that mean? Well, the angle is theta. The rate of change of the angle is d theta dt. That is what I need to solve for. So let me go ahead and label everything I do know. I know the bridge height is 16 feet. I'm going to call that y. Now, the moment when the line is 20 feet out, that is my z. And then, of course, the horizontal component of this triangle, I'm going to call x. And x I don't know, which I can solve for if I want to using Pythagorean's theorem. But let me go ahead and just construct what is it that I need to find. I need to find d theta dt. Now, I need to construct an equation that involves theta given from what I'm given. So what am I given? I'm given the opposite of this triangle. This is my opposite. I'm also given the hypotenuse of this triangle. And from trigonometry, we know that there's a trigonometric function that involves opposite and hypotenuse, and that is a sine function. Y represents my hypotenuse. I'm sorry, y represents my opposite, and z represents my hypotenuse. Now the thing is that the bridge's height is never changing. Notice, if you reel in a fish, the bridge's height never changes. So y equals 16 is a fixed value. It's a fixed quantity. The bridge's height does not change because you're reeling in a fish. The fishing line itself does change. Let me give you an example. In blue, as I'm reeling in this fish, the line of my fish is getting shorter from the bridge to the water, and the horizontal component of this triangle is also getting smaller and smaller and smaller. Okay, so what does that mean? That means that my z and my x are varying. So they're my variables. So I cannot express z as 20 yet because 20 is what the line is at that moment in time. So I'm going to leave my z the way it is. Now, sine of theta is equal to 16 over z, which is the same thing as 16 z to the negative first. Now, let me go ahead and erase this so we can have it all together. So it's 16 z to the negative first. If I want to find d theta dt, that means I need to take my derivative. The derivative of sine is cosine and then theta, and then chain rule times d theta dt because theta is also a variable. The angle is changing. And then the derivative of 16z to the negative first is the power rule, so it's negative 16 z to the negative second times dz dt. Okay, and I'm interested in finding d theta dt. Okay, so here's what we need to do. I need to get rid of the cosine that's being multiplied to the theta. So I'm going to divide both sides by cosine, or I can multiply both sides by the reciprocal of cosine, which is secant. Secant times cosine cancels, leaving me with d theta dt. Remember that negative 2 power is the reciprocal, so I can bring z to the bottom as a positive 2 power. dz d theta, I'm sorry, dz dt times secant theta. Now, before we start plugging in things into our equation, what does secant theta mean? From trigonometry, cosine theta is x over z with respect to the triangle that I drew. And since cosine and secant are reciprocals, then that means that secant theta is z over x. So I can replace the secant and write it as z over x. Now, before I start plugging in more anything into my equation, a z on top will cancel one z on the bottom. So I have my final simplified equation to be 16 z times x times dz dt. Okay, now I have everything that I need to know to solve for d theta dt. I have my 16, well, negative 16. I know what z is. I know what dz dt is. dz dt represents the change of the line being reeled in, and that is 2. It's already given to us. I do need to solve for my x, however, so I do that using Pythagoras' theorem, and I see that my x is 12. Go ahead and use Pythagoras' theorem just to verify what's happening there. So plugging in everything that I do know, d theta dt is negative 16 over 20 times 12 times dz dt, which is 2. Okay, so that means that it's negative 32 times 20 times 12. Well, let's go ahead and reduce this. 32 over 12 is the same thing as, well, what's 32 over 12? So let's see. That becomes 16 over 6. And that's also still reducible. And that becomes 8 over 3. And 8 and 20 are also reducible. So that means that my final answer should be 4 over 10. Sorry, I'm trying to do this in my head. So it should be 15 feet. I'm sorry, not 15 feet. 2 over 15 is my d theta dt, and theta is not measured in feet. It's measured in radians. So it's radians per seconds. And we did say that was a negative on the top, so that's negative. So the change of the angle between the line and the water is changing at negative 2 over 15 radians per second. So let's go ahead and illustrate this before we end this part of the video. Here's my angle. As I am reeling in this fish, my angle is changing. Notice how it's changing. It's going in this direction. It's increasing, but in the negative direction, because we know that counterclockwise is positive direction for angles. So my angle is changing in the opposite direction. It's increasing in the opposite direction, which is negative quantity. And then we'll go ahead and finish off example number 2 and 3 in the next video. Thanks for watching.